Good evening and welcome to my channel. Today we'll be looking at connection of solar panels in series. Taking you through this lecture is Engineer Ibinoba Charles, lecturer, Federal University of Petroleum Resources, Efru, Delta State, Nigeria. Why series connection? Connecting of several panels in series arises from the need to reach certain value of output voltage without changing your current. This simply means that the reason why panels are connected in series is because a certain level of voltage needs to be attained while leaving your current constant. That is the reason why panels are connected in series. For example, if you have a 24 volts system and you wish to put a panel into that system and each of the panel is rated 12 volts, when 12 volts panel is connected to that system, it will not be able to drive that particular system. Hence, you need two of that panel in order to drive that system, and to do that you need to connect them in series. So that is the reason why panels are connected in series, in order to increase your voltage and to leave your current constant. How is series connection done? When solar panels are wired electrically in series, as you can see, we have about four panels here. You see, the first terminal, which is the positive terminal, is left alone. Then the second terminal of the first panel, which is negative, is connected to the positive of the second panel. Then the negative of the second panel is connected to the positive of the third panel. The negative of the third panel is connected to the positive of the fourth panel. You will continue this connection until you get to the last panel where you have your negative and you leave it hanging. So this is your positive probe and this is your negative probe. When you put in your voltmeter between these points, you'll be able to measure the total voltage that is being generated by this particular arrangement. It is important to note at this point that when solar panels are connected in series, it is usually referred to as a string. In this study, we'll be looking at it under three different subheadings. 1. Series connection of solar panel of the same parameters. B. Series connected solar panels of different voltages. 3. Series connected solar panel of different current. So we look at the first one, series connected solar panel of the same parameters. Here we are having three different panels. We have panel 1, we have panel 2, and we have panel 3. Each of these panel is rated 12 volts 5 amps, the second one 12 volts 5 amps, and the third one 12 volts 5 amps. So all of them are having the same parameter. So the total power of each panel is simply power P is equals to I times V. So by the time we say 5 times 12, that is going to give us 60 watts. So this panel is rated 60 watts. This panel is rated 60 watts and this panel is rated 60 watts. So we can also say that all these panels are having the same wattage. Now, to connect these panels in series, as usual, we connect the negative of one to the positive of the other, negative of one to the positive of the other. Then we leave the negative probe hanging, then we leave the positive probe hanging. So the question now is, what is the total voltage when these panels are connected in series, and what is the total current when they are connected in series? So this is it. The total voltage is equals to the summation of the individual voltage of all the panels connected in series. So you take the voltage of the first panel, you add it to the voltage of the second panel, and you add it to the voltage of the third panel. So that gives us 12 volts plus 12 volts plus 12 volts, making it a total of 36 volts. While your total current is equals to the current rating of one of the panel. So like we said, when systems are connected in series, the aim is to increase the voltage while maintaining a constant current. So that is why you take one of the panel current such that your I1 is equals to I2 is equals to I3, which is equals to 5 amps. So the total current produced by those three panels is equals to 5 amps. Now, what is the total power? Your total power P is equals to I times V, which is equals to 5 amps times 36 volts, which is equals to 180 watts. So that is the total power generated by the three panels. We take case number 2, series connected solar panels of different voltage. Again, we have three different panels. They are connected in series. The first one have a voltage of 6 volts 5 amp. Second one have a voltage of 12 volts 5 amp. And the third one have a voltage of 18 volts 5 amps. So the total power for this first panel is 5 times 6, which is equals to 30 watts. For the second panel is 5 times 12, which is equals to 60 watts. And the third one is equals to 5 times 18, which is equals to 90 watts. So we notice that each of them also have a different wattage. So in this case, all we need to do in order for us to calculate our total voltage is the same thing. The total voltage is equals to the summation of the individual voltage of each of the panel. So we take the first panel 6 volts plus the second one 12 volts plus the third one 18 volts. So when we add the three together, we have 36 volts, and the total current is equals to the current rating of one of the panel. So that with IT is equals to I1 equals to I2 is equals to I3, which is equals to 5 amps. Again, our total power P is equals to I times V, which is equals to 5 times 36 volts, which is equals to 180 watts. It is very important to note here that for every panel, the manufacturer always states the standard panel voltage. Let us take for example, we have panels that are rated nominal voltage of 12 volts. We have the one that is normal voltage of 24 volts, and we have the one of normal voltage of 36 volts, and so on and so forth. But these voltages, they are usually changed a little as a result of the amount of radiation that is being received by the solar panel. For instance, on a very sunny day, when the open circuit voltage of the panel is measured, that is to say, when there is no load connected to the system and the voltage is being measured, you will notice that the voltage measured will be far higher than the rating of the solar panel. For instance, let us take this case for example. The nominal voltage of this panel are rated 6, 12 and 18. So the total voltage produced by this panel is 36 volts. So but during a very sunny period, you might measure up to 45 volts, which is usually equals to 1.25 times the nominal voltage of the panel. So by the time you take 1.25 of this nominal voltage, you are going to get about 45 volts. So during a sunny period, this particular arrangement will give you 45 volts. So this is very important when you are trying to do your calculation. After looking at the nominal voltage of the panel and you have done your calculation, you also take into consideration the fact that during the sunny day, calculate the change in voltage you are going to get, such that when you are trying to match your system to your solar charge controller, you'll be able to select an appropriate charge controller in order not to damage your charge controller, because charge controller are rated based on the maximum DC voltage they can carry. So take into consideration that when the sun is high, what am I going to get from the voltage? This is very necessary in order not to damage your solar charge controller. So we take the third case, series connected solar panel of different current. So again, we see this panel 12 volts 1 amp, we see this panel 12 volts 3 amps, we see this panel 12 volts 5 amps. So it's clear that all of them are having a different current rating and they are having the same voltage rating. So let us try and make an assumption here. The assumption here is that, let us calculate again the wattage of each of the panel. So let us take the first panel, which is 12 volts 1 amp. The total wattage is 12 watts. The second panel again, 12 volts 3 amps. So 12 times 3 will give us 36 watts. And the third panel, 12 volts 5 amps. So the total wattage is equals to 60 watts. So by the time you add the 3 wattage of the panel, P1 plus P2 plus P3, we are going to get a total wattage of 108 watts. Now, let us go by our calculation. When panels are connected in series, we do what? We add all their voltage. So the total voltage equals to V1 plus V2 plus V3. So we have 12 plus 12 plus 12, which is equals to 36 volts. And from the arrangement, which of the current are we going to take? Because now they are having different current. So by law, when panels are connected in series and they have different current rating, it is the panel with the lower current that takes the lead. So in this case, the current we are going to take is 1 amp. So that means the total current is equals to I1 is equals to I1 is equals to I1, which is equals to 1 amps. Then our total power P is equals to I times V, which is equals to 1 times 36, which is equals to 36 watts. So it is very clear that our assumption we made, which is this particular assumption of the total power, is wrong, because the actual panel power produced by this arrangement is equals to 36 watts, clearly reducing the actual wattage of the string to 33% of the maximum power. So this is very important when we are doing our installation. You must have come up with your design, selecting a particular value of panel, current and voltage. But during design, it is very important to monitor the installation such that the parameter of any of the panel is not altered, because if any of the panel within the string, the parameter is different from the others, that panel with the lower current rating that will take supremacy of the entire system, thereby making the customer to invest so much money in the system and getting at a very low output. So it is very important after design, always monitor the installation as an engineer. In conclusion, for you to achieve maximum output power in a string, before connecting panels, two conditions must be met. Condition number one, must have the same voltage and current. So any panels you want to connect in series, make sure that they have the same voltage and the same current. Number two, they can also have a different voltage, but the current must be the same. So in summary, before panels are connected in series, make sure that all the individual current of the panel are the same. Try this and leave your answer in the comment section. 3 solar panels of 6 volts 60 watts, 12 volts 84 watts and 24 volts 144 watts are connected in series. What is the total power output of the string? So all you need to do, just let us know the total power that is being produced by this particular string, and leave your answer in the comment section. If you find this lecture very interesting, I want you to like this video, share it with your friends, subscribe to my channel for more interesting lecture series. Thanks for watching.